Raoult's law is utilized whenever we talk about vapor pressure. Now we can remember that vapor pressure is one of our colligative properties, and a colligative property is essentially a property that will change when solute is added to the original solvent. So let's say we have liquid water. Now we know liquid water will boil at 100 degrees Celsius. When that water starts boiling, we get this phase change from liquid to gas. So we get these gas particles, and we refer to this as vaporization. Now, if this was a closed system, let's say the water is evaporating within this sealed glass container. When the water evaporates, once it reaches the surface of the glass container, it will condense and come back down as liquid water. When we reach equilibrium of vaporization and condensation, that's referred to as our vapor pressure. Now, the vapor pressure is going to be specific for a pure solvent, and it's going to change when we add solute. When we add solute to our liquid, that solute is going to disrupt and come in between our liquid particles, and that's going to cause our boiling point to first of all increase, because we're going to need a higher boiling point in order to vaporize those liquid particles. But also, since those solute particles are disrupting the vaporization of liquid, we get less vapor. And if we get less vapor, we're going to have a lower vapor pressure. Okay, so essentially, when we add solute to a liquid, our vapor pressure will decrease because the solute will disrupt the liquid and prevent all that liquid to turn into vaporization. So it lowers our vapor pressure. How can we quantify the decrease in vapor pressure when solute is added? Well, that's where we see Raoult's law. So Raoult's law quantifies the decrease in vapor pressure of a solution when solute is added. And this is the formula for Raoult's law, where we have P sub A equals X sub A times P pure. Now, P sub A refers to the new vapor pressure. Now, we can remember that the P stands for pressure in this case. It's a little confusing because we're talking about vapor pressure, so we think it should be V, but in reality it's P and it stands for pressure. So P sub A is the new vapor pressure. X sub A is the percentage. This is really important. It's the percentage of solvent in the new solution. And then we have P pure, which is the original vapor pressure. So if we're given two of these values in a question, we can easily figure out the third value with simple algebra, because this equation is fairly straightforward. We just have to remember that P sub A equals X sub A times P pure, and what each of these stand for. Now let's do an example problem. So let's say that the original vapor pressure of water is 760 atm. In a lab, you make a new solution consisting of 25% methanol and 75% water. What is the new vapor pressure of water? So let's highlight some of our key terms. It says the original vapor pressure of water is 760 atm. Now, it says that in a lab, we create a solution consisting of 25% methanol, 75% water, and it's asking what is the new vapor pressure of water. Now that we've highlighted our key terms, let's label what we know. Now remember that P pure is the original pressure of our solvent. Now first we need to determine what our solvent is, because we're given two different substances. We're given both water and we're given methanol. Now in order to figure out which one is the solvent, we take the one which is in the higher concentration. So we know that there's more water than methanol. So water is the solvent because there's 75% water, 25% methanol. There's more water, so water must be our solvent. So since water is our solvent, what's the original pressure? What is P pure of water? P pure of water is going to be the 760 atm. Now, so we're going to label out P pure to be 760 atm. Next up, we have to figure out X sub A. X sub A defines the percentage of solvent in the new solution. So in the new solution, we have 25% methanol, 75% water. We know that water is our solvent, so we have 75% water, and that is our percentage. Of solvent in the new solution. But what's important to note over here is that we have to convert this 75% into a decimal, so it's actually 0.75 because we divide by 100. Now we have both of these values, and the question is asking us what is the new vapor pressure of water. So we're solving for the new vapor pressure, which is PA. So if we say PA equals X sub A times the P pure, we know XA to be 0.75, and we know this to be 760 ATM. Now, if we multiply those two values, 760 times 0.75, we get 570 ATM. That is our new vapor pressure of water. Now, this question is a little different from the previous question because it's asking us what is the new vapor pressure of the solution. Now, remember in the previous question, it was asking us the vapor pressure of water, but in this case, it's asking us the vapor pressure of the entire solution. So let's highlight our key terms here. It says the vapor pressure of water and methanol is 760 ATM and 0.128 ATM. So in a lab, you make a new solution consisting of 25% methanol and 75% water. What is the new vapor pressure of the solution? So let's start off by determining the vapor pressure of the water. Now this value is going to be the same as the previous page, but we'll do it once again just so we know what we're doing. So XA times P pure times P pure. Now recall that XA, the percentage of solvent in the previous question, was 0.75, and we multiplied that by P pure. So if P pure for water is 760 ATM, and we got the value of 570. So this is PA of water. Now let's determine what we're going to get for methanol. Now we're going to go PA equals XA times P pure. Now I want you to remember that we had 75% water and we had 25% methanol. So in this case, we're going to put 0.25 because we're talking about methanol in this question. And then for P pure for methanol in the question, it's given us as 0.128. Because remember, P pure is the original vapor pressure. So if we multiply these two values together, 0.25 times 0.128, we get 0.032. Now we have these two values, one for methanol and one for water. Now to find the total vapor pressure of the solution, we simply say PA is going to be equal to 570 plus the 0.032. So we get 570.0.032. And that is our final answer. So essentially we find the individual vapor pressures and then we sum them up. This means that if we want to find the vapor pressure of a solution, we can summarize and create this new equation where we say that PA is equal to XA times P pure of the solvent, and then another XA times P pure for the solute. So in this case, we could say this one is methanol, and we could say this one is water. And this equation can be used to find the vapor pressure of the solution. And that is essentially Raoult's law. It's a way to quantify that decrease in vapor pressure due to the addition of the solute.